Question number 8 is a little bit tricky, so let's see how we can approach this problem. So it says here the limit as n goes to infinity of the sum of the terms from k equals 1 to k equals n of this expression square root of 1 plus 3k over n times 1 over n. So how do we interpret a problem like this? Well, if we take a look at this limit as n goes to infinity and we take a look at the last term, 1 over n, essentially this term is becoming a 1 over divided by infinity, and it's making our multiplier tend to 0. So this is similar to dx. So it's behaving like dx. So I'm just going to rewrite this again. So we left with here the limit as n goes to infinity, the sum of the terms, which we can think of as an integral, and we're going to end up with an infinite number of terms of square root 1 plus 3, and I'm going to write this as k over n, and then we're going to kind of interpret that 1 over n as n goes to infinity as dx. Okay, so if we let n go to infinity in this expression, essentially we're going to end up with k over infinity. And so I'm just going to replace that n with infinity, and k over infinity is going to be essentially 0 if k equals 1, and if k equals infinity, okay, we end up with 1. So if we interpret this piece, so we're going to do this, we're going to let the k over infinity, k over n, we're going to let that equal to x. If that's the case, then k over infinity tends from a value of 0 to 1. So we're going to then say that k over n is equal to 0 when k is 1, n is infinity, and it's going to be equal to 1 when k is infinity and n is infinity. And so what that means then is we can let the x values, if we interpret that as x, it's going to be equal to from 0 to 1. So now what we then have is, when I replace this, and I'm just going to do this in different colors so you can follow along. So if we let that be the case, then I end up with this expression, limit as n goes to infinity. We're going to end up with the sum of the square root of 1 plus 3x, and the x value is going to go from, so n equals, x equals 0 to 1. And now at this point we don't need a limit anymore because we've allowed the n to go to infinity. And we also have this dx over here times dx. Let's do a different color. Keep track of that. So we have times dx here, and that x is coming from that blue expression. So now at this point we can see that it's starting to tend towards one of these values. So now I'm going to, instead of using that sum, I'm going to use this summation from x is 0 to 1, 1 plus 3x times dx. So the answer is A.